I'm Rong Singh, and I work on developer tooling for various projects. I also run a group called the White Paper Reading Club, where we hang out and read papers together. I've been working in space since 2017.
My name is Brian. I met Rongxing through that white paper reading club. I currently work at Polygon as Senior Developer Relations Engineer. I do protocol research and a lot about ZK VMs, and a lot of interoperability.
In this episode, we break down a new way to build and think about blockchain apps. We explore Brian's new A to Z framework, where apps run like Web 2, but maintain trust through off-chain execution and on-chain verification. We discuss the decoupling of execution from trust using tools like ZK proofs and trusted hardware. We cover user experience, wallet abstraction, layer 2 security, and cross-chain design. And we show the first of its kind application through the ZK Hyperliquid, a performance spot exchange.
So you recently did the A to Z app. I don't know how you came up with the name. Maybe what is the context for the name first?
I actually mentioned it in the tweet. The idea of this app framework, it's basically a chainless app chain. So, before, when you wanted to build your own app chain, you have to deploy a layer 2 first, and then deploy your smart contracts on top, and then you're just using those EVM infra and stuff. But what we're proposing here is, why would you limit your app to EVMs, right? And why would you limit your apps to some of the wallet scheme? Why don't you just build a Web2 app, but use trust layers that can verify the executions, and then you submit that trust proofs or trust attestations to trusted environments like layer 1 or maybe app layer, etc. It means we're decoupling the executions and the trust layer. I would say hydrogen layers approach is similar too. They have the AVS that verifies their task, but also you run different services off chain where you can just run any computations like DA layer or ZKTLS, etc. And then you have verifying services. If the verification passes, then you accept the result. If not, you punish them by proning. There's a punishment mechanism. But we can swap that trust component into a ZK VM or into TE or into consensus, etc. Right now, we just need to build a pipeline for it. And that pipeline is what we're calling this A to Z apps. And to answer your question, why A to Z? So in regular expression, a hyphen Z in a square bracket means you just select one character from A to Z. So this can be a V app, so VAP, which is a verifiable app. It can be T app, trustless app. It can be Z app, which is ZK app. It can be AAC, which is like ACK layer app. We thought about a lot of different names to put in front of that app. And then we realized, if we can just put all the alphabets in front, why don't we just aggregate them and then use regular expression?
For those that it's not nerding out as hard, it's a way to match strings. Like when you're coding stuff, you have to sometimes match words, like match a particular part of a URL or regular expression, its own scripting language, which allows you to do this. But the idea was you started off thinking about a framework that allows people to build like Web 2 UX type of applications that is truly trustless. But then there's all these ideas around like app chains, where a particular app will run its own chain that then settles all of the transactions and everything to Ethereum. But you're saying that an app shouldn't really need its own chain. It just needs the verifiability that all the transactions and everything on this app was done correctly. So a chain is an overkill for these applications. A question that I have is, I don't see anything about wallets. How do people interact with the project if there's no wallets?
Yeah, I think first off, the idea of this, it really started from how can we scale blockchain to mass use cases? And what are some of the bottlenecks? As we know, it's about onboarding, which is the wallets, the gas fee, and also the network itself has been slow. Of course, nowadays we got Solana, we got Hyperliquid, all of these solutions, they're pretty fast. But there are a lot of other use cases that is happening on the Ethereum ecosystem that is not fast enough. So we start to have Mega ETH and a lot of other solutions. But that doesn't mean that we will just settle on Mega ETH. Every chain, every app should be fast. And there has been a lot of explorations. The ultimate version that I see, it should just be, we have Web2 app, right? We have Web2 app, and it should just be the exact same experience, or maybe some modification. Of course, I'm just exaggerating a bit, but
Yes.
just imagine the exact same Web2 experience, but you just wrap a trust layer on top of it, basically. That's how I imagine. That's why I didn't mention too much about wallet. But yes, it will need some sort of account system, because it's going to come with this cross-chain interoperability by default. So what does that mean? It means other chain can send assets to your chain or to your app, and your app can withdraw assets to another chain, etc. So that means it does require some sort of an account management system that tracks the balances, etc. on this app chain. Of course, your app chain can be configured into, oh, I don't accept money anymore or whatever, but that kind of lose the point of blockchain. So let's just assume that the apps that are going to build on top of this A to Z framework is going to be a token enabled applications. But it's just how are you going to manage those tokens per account in your system? There's a lot of ways. You could just use the Web2 way. Like you have a database and then you keep track of this user has this amount of token, etc. And you just need to have a mapping between your chain, your app's asset tracking system versus the Ethereum style. So whenever there's assets coming in, you can translate that to your app chain state. And when there's assets going out, you also translate it back to the EVM style or the ACK layer accepted style, which is the pessimistic proof requirements. That's another topic to talk about. But yeah, so in that sense, the easiest way, of course, is just use the Ethereum's account system where you have nuns, all that stuff. But what's really necessary is just two things, right? You need to have an account, which is a public key. And then under that account, you got tokens and then the balance of that token. And that's all that matters from a cross-chain perspective. As long as we can explain that well, as long as we can integrate those key standards into your app, then it will just work. And the way you achieve it, you can use the wallet system or you can build your own, right, for a better UX. So user, whenever they log in, they can use Google to log in, they can use their email and password to log in, and then you assign a public key to them to extract away those kind of complications. And this will just feels like a centralized exchange, right? Because centralized exchange, essentially, you sign up, you verify your KYC, and then you get an address where you can import into, and you can withdraw the money from that to another chain. It would just be the exact same experience. But the operations that you do inside your centralized exchange, the address doesn't matter, right? It's all about the app experience. So that's being abstracted away.
I like this analogy that you just said. Imagine you can have a regular Web2 app or some sort of application, and then it's like a very pluggable trust system. You can provide an additional layer of essentially verifiability for the application developers, make it easy for them to do it. I feel like there's a slightly philosophical question, and then we should dig into the particular components. One thing that I found with stuff like Bitcoin, everybody can verify that a transaction was false. If somebody tried to double spend or somebody tried to do something, it's very clear as long as 50% of the people are good, they will not accept it into the chain. And even if at some point they do, then people can fork off. But there was no incentive for people to verify transactions to make sure that there was no fraud. And I don't know if this is a correct way to think about it. For instance, in Bitcoin, the idea is always just to follow like the longest chain. But my point is there's no like watchtower people that will go and verify this actively. Like they're not incentivized to do it.
Actually, it is in the design itself. If you wanted to spend money, you have to have, this is the concept where the decoupling, what I'm trying to say here is Ethereum or Bitcoin, etc. The execution and verification happens at the same time. But whereas on this scalable infra,
Yeah.
that A to Z app, as an example,
Yeah.
will be more so about you execute first. But of course, you execute it in a safe environment. And then we generate a proof of your executed results. And of course, there's a couple of ways of verifying your executed result is correct, right?
Mhm.
Which we'll dive into in a bit. But yeah, basically, like Polygon POS is still coupling the execution and the verification together, but to a limited set of nodes, 100 nodes. That's why it's being able to do it way faster than Bitcoin or Ethereum. But also that loses security. But if we start to decouple the execution and the verification, whereas we execute first, you either decide to find ways to secure the execution environment, or you just ignore that and then you just verify the result only. So
Mhm.
that's why the ZK layer 2s, the sequencing is basically centralized, right? Most of them.
And just to be clear, in a layer 2, is the sequencing the execution layer?
Yeah. So the sequencing will be because to the transactions, and then they have the mempool, and then they build a block. So that's all execution. And if you're not decentralized layer sequencer, then you're pretty much just a centralized server that are doing that.
Right.
You could insert your transactions. So that's that. But people are still using it, right? Because they know that at least the state transition is correct. So it's either you
Because
include the
the
transaction.
core state, it's stuck on Ethereum, and you need private keys to essentially sign stuff to change the state. Is that why you cannot change it? Is that the context? Like, I'm just thinking, like, why can't like a layer 2 just steal all of your money?
Layer 2 can't, of course, because first off, layer 2, if they want to steal our money, they need to have our private key to access our account, to actually do transfer, etc., to their own whatever account. So they need to do that. Or so that's essentially why. But of course, they can always arbitrage you, or they can always manipulate your transaction. They cannot change your transaction, but they can change the environment around your transaction. They can insert stuff before, they can insert stuff after, etc. to
Or they can
play around with
transactions. Yeah, I see. So, okay, so that at the core, they can't sign and really transact on your behalf because the state, the true state of like how much money you have right now, at least it's derived from the layer 1, which is Ethereum.
state itself can be stored on layer 2, right? The layer 2 also maintains states of users in layer 2 alone. They only submit their state reference to layer 1. So basically the entire layer 2's blockchain states is being uploaded to layer 1 from time to time as an anchoring or git commit. It's just, oh, I'm submitting a claim, say, oh, this is my state, and Ethereum accepts it, Ethereum stores it, then that's the source of truth that everybody can reference on. And Ethereum is a safe blockchain. That's why people wanted to do that with Ethereum.
So then if let's say I launched like a token or like a meme coin on a layer 2, and it's native to the layer 2, can the layer 2 just say like empty my balance and then just submit it to Ethereum, and will that transition work?
It depends on who's doing that action, right? If it's like user doing it, if users like withdrawing funds from layer 2 to layer 1, there's a couple of steps, right? User first has to initiate the transaction on the layer 2, and then layer 2 has to include that transaction in the block. So that's up to the layer 2 sequencer to decide, right? If it's not malicious, then it's pretty much probably going to include that transaction at some point. And once it's being included, it's also up to the layer 2 to submit the block to layer 1 so that it's being verified, so that then you can withdraw with that sort of a layer 2 commitment to layer 1. So there's a couple of dependencies on the layer 2 end, and it is not trustless. So layer 2 still has to do all of those commitments to keep the system healthy. But economically, it is the incentive to that they should keep the network healthy. Otherwise, like no one is gonna use their chain.
I'm just thinking, for instance, can a layer 2 essentially is my security protected in part really just by like digital signatures, right? Like when I submit a transaction on a layer 2 that says, okay, I bought like 100 meme coins, the layer 2, they could just submit like some like a fake transaction that says, oh, I sent this 100 meme coins to somebody else, but because they don't have my private key, they cannot sign on my behalf.
As long as you can generate a block, you can create a block that layer 1 can accept, then yes, it's going to work. But for layer 1 to accept, it means you need to have the previous block state and the latest block state, and then you have to block all the transactions as the state transitions from previous state to the current state. So it's basically past, now, and then the delta. You apply the delta to the past, you get the now state, and is it correct or no? The proof generation itself is basically proving that transition is correct. And on the verification end, you just run the verification of the proof. So it comes in a set of the ZK system, the prover and the verifier. Like each transaction has to be signed by someone, right? You can't just insert a transaction it's not owned by anybody. It has to be owned by someone with a private key that signed it. So that makes a blockchain a good system, right? So even if you're building this sort of an app chain without EVM concept, you should have some sort of a signing capability. But if you just want Web2 US, maybe not that necessary.
So maybe
this has been a long ongoing debate. And at this point, with all the layer 2 has been running and has been successful, maybe that's not so much of a focus for a lot of people, because time has proven that they're not economically incentivized to do that kind of harm, even though they're a centralized sequencer.
Maybe this is where we discuss what you've been building, which is around this idea of a ZK Hyperliquid. It's the initial application that's built on top of this A to Z app framework. How did it happen? What was the context? Like, how did you guys even think about this?
I feel people care a lot about performance, and we've been thinking, how can we increase performance to have a better UX, right, for people? And of course, I feel maybe sometime next year, every chain will be hyper performant. It will be standardized. If you're not performant, you're not computable, right? Of course, Ethereum being a little bit of a different case because there's layer 1 that everybody lives on top of. So they just need to be super, super secure. But yeah, every single layer 2 will be hyper performant for sure. How do we achieve it? We can do it via Flashbot has this something called the Flash blocks.
We start, what is Flashbots?
Oh yeah, if you're in the Ethereum world, then you heard of the word MVV before, maximal extractable value. Basically, it's this driving layer. Let's say if you have a transaction that you really wanted to be included fast, instead of placing a really high gas fee and then you throw it into a random RPC, wishing some miners will pick up your transactions and include it into the block, instead you talk to someone, you bribe them saying, hey, you know what? Maybe you don't pay as high of a gas fee to follow that auctioning, but you're still paying some premium to these groups of people who are block builders, but they teamed up together. So they're a group of block builders, and you bribe them. And then you say, hey, this is my transaction that I really wanted to include. Can you please help me do it? And then, they will take the fee, and then they'll help you include it in a little bit more expensive, but more stable way. So that's like what they're doing. So they were all about this sequencing. The whole entire product line and theories and etc. They've been pioneering this space for really long. It's all about sequencing. And what they have proposed for Flash Block, which is similar name, but it's not bot, it's block. And what they're proposing is, I'm just gonna read this. Flashbox is a streaming layer that gives user near instant UX while still running an explicit auction every 250 milliseconds. 250 milliseconds is very fast, just so you know. I think Solana is probably like 400 milliseconds. But yeah, it's really fast. It's even faster than Solana. So speed won't be an advantage for Solana in probably a year or so. But everyone's gonna be fast. And we're being really creative here regarding blockchain's architectures. Flash block is doing is they're running the mempool, the sequencing, the ordering, all that stuff, and the execution, everything inside the TEE. So TEE is basically a trusted execution environment. It's a dedicated section on your computer or CPU that is non-interruptible. If you throw in a task, they will finish running it, and then you cannot interrupt the process, or you cannot insert whatever your whatever task and etc. or your transaction. You can think of it as a black box where you throw in something, it's going to give you something out. Think of this TEE part as the execution part, right? We talked about the ZK layer 2. They have the sequencing, which is the execution, and then you have the ZK proof, which is the proof generation for the security, right? And that's basically the inspiration. It's then maybe we can create this kind of a sort of a stack where we can fulfill the performance requirements and also the safety requirements by decoupling the execution and the security. What is a good example for that, right? So we're like, Hyperliquid it was really hot like a couple months ago, and then but the thing is, like, I think they might be wrong, but I've heard they are layer 1, yes, but they only have 6 nodes running. So it's not that safe. If you think about it, like only 6 nodes, it's not that safe if you're like a public blockchain. Because look at Ethereum, you got like thousands, or I don't even know how many numbers of nodes are out there, but it's just a lot of nodes. Don't quote me on the numbers, but it's just a lot compared to 6 nodes. It's the safety is definitely not a thing. Hyperliquid, I would say, compared to Ethereum. But of course, they probably spent a lot of money on it. But can we change that safety module from consensus module to something else? Can we use ZK? And the advancement of ZK VMs recently has really shown us the possibility. So we can really, if we can design our code in a way where you have a previous state and you have a new state, and then you have transitions, the deltas from previous state to the new state. As long as you can describe this logic in Rust, then you can basically prove anything. That is, this was previous, this is the new state, and this is the state transitions. I can prove the correct state transitions. So that opens up a new possibility. So I don't really have to run EVM on top of ZK VM anymore. I can just run any custom VM. It could be your app-focused VM, right? In this case, will be ZK Hyperliquid. So that's why. So in conclusion, we were trying to find ways to build this hyper-performant, but also really trustable infra. And a good example for that would be Exchange. And Hyperliquid has been famous for it, so we just use the name Hyperliquid. We're not perpetual, we're just spot exchange, or at least this example is. So it's just a name that we used.
So the thought is that maybe one thing I want to just understand first, which is that you said they can use any sort of VM and prove that the transactions were correct.
Yeah.
It was ordered correctly. So like, how does this work? So if I have some program, and then like the ordering of the program goes through this, like the transactions, let's say this is an exchange, you wrote it in like Rust or another language, and it's like ordering. I bought something, you bought something, and my transaction was first, your transaction was second, and this is done inside of this ordering is done inside of this trusted execution environment, this little like secure hardware thing. And then my understanding is that the logs of this, like what is being proved by the ZK VM, or is it like the ZK EVM? What is that part?
Yeah, I might jump into the details too soon. I think it's easier to use examples to explain.
Yeah.
So let's just take a look at how ZK Hyperliquid is being implemented. So by any VM that you can run on
And by
ZK,
the way, it's open source, right? Like a lot of it, it's
Of course,
there's like a GitHub for it. It's pretty dope.
yeah, we're gonna share like a screenshot of it, whatever. Yeah.
Okay.
But there's a diagram, so I would just assume that it's in the middle right now. But yeah, by VM that runs on ZK VM, what I meant that VM is basically just a finite state machine. So if you're from computer science major, then you know it's in almost every programs. Turing machine, it's all of these are finite state machine, right? You have a start, you have an end. And then you have in the middle, you have state transitions from one state to another. And you can describe it in any language, any like coding language.
Wait, you talking about this thing?
But it's just a lot of components, that's why. But by the way, this is a demo, it's not finished. So in this case, in ZK Hyperliquid, the finite state machine will basically be the user's balance changes based on the match orders, right? So user balances is going to be states, and matched orders are the delta that is going to cause the change of user balances, and then you get a new user balances state, right? That's the logic. You have the past, you have the new, and then you have the delta that describes the change. And you're basically running this sort of a delta, this from past to new sort of a state transitions inside ZKVM. So that's the VM, quote unquote VM. But it's more so of like your application state transition logic. Yeah. And but that's the prover part. And the execution part is basically it's just a typical web tool, but with a little more components like the block builders. But to really start, you can think of, so if you look at the, come on, let's go back to the diagram.
Okay.
Yeah, if you look at the diagram, it's like you have front ends on the, you have users.
Wait,
on the
when I
very
do this, does the screen zoom in?
Yeah, it does. It does.
Okay, it zoomed in, right?
Yeah, it's very good.
Cool,
All right.
cool.
So you have users on the left who are interacting with the front end. So they would just use this app like a Web2 app. They might not even have a wallet. Depends on how you design, right?
Yes.
And then they just interact with it. They just place order. They just place whatever. Look at the chart, and then they have a candle, whatever chart that they can see in the front end, and they can place whatever their order, and then they can see the status of their order.
Yes.
And then they move on to those orders are passed on to the backend service. And the backend service has an RPC basically receiving the order that user placed. So you scroll right a little bit. Yeah. And then that's enough. Okay. And then the backend service will receive the order and then append it into order mempool. And then inside order mempool, basically they just rank those orders based on the price. And also when the price is same, they base the prices based on first in, first out. Right? So it's just like pending transactions wait to be matched. And then you pass it on to the order matching engine, which is on the right. If you scroll right a little bit. Here you go. The order matching engine will be constantly fetching the latest transactions from the order mempool. So in a ZK rollup perspective, it would just be the order matching engine will be the sequencer, right? The sequencer that is fetching from the transaction mempool based on the gas fee. And in this case, it will be the order mempool for spot trading in the mempool. And then the order matching engine will be that sequencer, but they select those orders based on their algorithms, right? But it's most likely like just match transactions, right? Or whatever computation. They can match a lot of transactions, etc., but it's up to the design of the order matching engine.
Right,
This is a very dummy version.
Yes, like you're saying, this matching part, it can be customized. It can there's always
already customized, right? Just like sequencing, right? You can't customize it to an MVV version. You can customize this into whatever your version as well.
So then let me ask then, which part of this, so if I was to understand, which part of this is run inside of this like trusted execution environment? Is it the order mempool and the order matching engine?
Yes. So it's going to be the order mempool and the order matching engine.
I see.
Yeah. Okay. And then
so the idea for this, the benefit of this is that when a user submits their transaction, the order, it's guaranteed. Let's say I cannot mess with it, regardless of whether I'm like,
it's play by the rule, basically.
Yes, like the rule is public, you can verify it, and then same with the order matching. You know that it wasn't matched by some other rule other than the one that was like agreed upon.
Yeah. So the verifiability is actually a little bit hard to say, but it's just you can assume that at least they are doing the right thing. Server's not doing the wrong thing, and because they're running in the TE. But the order matching engine, they can still swap it with another engine, but you would never know.
You wouldn't know. But
Yeah.
there was a thing. I was at like a small workshop with Andrew Miller and
Oh,
at University of Illinois, and I think he's working with the Flashbots team right now, and he's all into secure hardware. And we were running this thing, and then I'm just trying to. The discussion was, how do you actually verify that the program that is being run in the TE? Like, how do you know that this is the program? And it looks like the simple way of doing it is like the TE will spit out a sign. It's like they sign some like hash that represents the code. And the idea is that you can then go to GitHub, compile down this piece of code, and then get the hash and verify the signature.
so GitHub is basically like but then you have to open source your order matching engine then.
Right.
For a
So
lot
that's
of
like,
companies, yeah, for a lot
they
of
don't want to
companies,
do it.
that's their secret.
Yes.
But
Yeah.
no, I like this idea. I actually heard it too. Now that when you're speaking about it, I've heard it too. Yes, that makes sense. And it's basically there's an attestation available in a third party, and you can demand it to spit that out, the signature, or whatever, the hash of it, and then you
Yeah.
match it. It's just like the attestation that we do in blockchain, but this time we're using in the context of TE. Yeah, totally makes sense.
Right.
That's actually very smart. Yeah.
Yeah. And then I guess then in this world, then the matching engine and all this, everything needs to be open source. Like this only works if it was.
It depends, right? Depends because centralized exchanges they don't open source their order matching engine, but
Right.
people still use it, right? It's the goal that you wanted to reach that changes your configuration of your app. It's never about we just want the best tech or you just want the best whatever. It's more so who are the user that you're serving, and will they feel justified with your security setting? If not, they would choose other products. So do your market research and decide on the right tech to use. But yeah, I think providing that sort of a safe portal is
Yeah.
really helpful for sure. It's very helpful. But I do see like this kind of a template. It's definitely going to be out there, like an order matching engine on top of this sort of A to Z sort of framework is definitely going to be out there. A lot of people are going to build on top of this sort of a template to build their own dexes that can connect, that can be app chain itself, but it has native bridge that connects to these other blockchain ecosystems. So money coming in and out is super smooth. So it would just feels like running on the same chain. Yeah.
Understood. Afterwards, later in I want to get your thoughts on some of this like cross-chain stuff, but maybe we should continue with this first, or what do you think?
Yeah, no, it's almost there.
Yeah,
Just,
that's like the key parts, I think.
yeah, the TE part is the order mempool and the order matching engine. But after you've matched all those orders, now you just have a bunch of execution traces, which is the technological term. But I would say it's basically
where is the execution traces? Is it? I don't have a pen or something. I don't know. Can I use a pen?
So there's no.
Is it like here? Is it this a pen transaction dumping? Is that the trace or?
So all the matched orders, I describe them as execution traces in this example.
Okay.
But yes, you can also run the order matching engine inside ZKVM, but it's gonna slow down the performance tremendously.
Yes.
So it makes sense to actually just run the order matching engine in TAE to have a soft trust. So it's not like 100% trust like ZKVM, but it's still good enough that we can trust it. But inside ZKVM, we only run the state transitions. Yeah, we only prove the state transitions of the matched orders. So matched orders are basically those execution traces from previous block to the current block, or from the previous state to the current state. You have a bunch of state transitions that needs to be included into block and generate a proof for.
Right. So state transitions, like my account has 100 now, and then I send one. So now there's this transition from 100 to 99.
Yeah.
It's like a list of these like state transitions. Like your account, my account now, previously 100, now 99, because I sent something in between. Brian's account was like 99. Now I sent him one, and then now it's like 100. And then there's like this huge list of all the changes in people's account. Is that kind of
exactly?
so that's what you mean by
In this case, won't be the sending money state transitions, is more so about matched orders. So it's always going to be us swapping assets per entry. Yeah. So you have, and then you have a bunch of them. Now the block builder's job is basically, now that you have a buffer of those, you just need to constantly building those, batch them into blocks, and constantly build them, and then send it over to the ZKVMs to generate proofs.
So you have a giant list of these, and then they become a block. I see. So there's actually, can I say there's almost like two mempools, if it makes sense?
Yeah.
There's one mempool that all the transactions go into. Once the orders are matched, then there's like a second mempool, which is the actual one that the block is going to be built on.
If I really use a good term for this, I would say, first is, so when from user to before being sequenced, I will call it just mempool. And then after that, the sequenced ones, I'll call it a confirmation mempool. So because these are being confirmed, they just need to be included into blocks. So there's additional step compared to the ZK, compared to the layer ones or whatever. Because for a lot of those blockchains out there, when transactions are being included in the block, then the block is immediately being proposed and trying to be synchronized, etc. Whereas here, depending on the speed of your backend, you can do it that way. So you don't really need this sort of confirmation mempool. You can just keep on building the blocks. Yeah, you can do that too. It's up to the performance, it's up to the cost, it's up to the UX, how you want user to feel about your exchange. But just so you know, users' experience on this front end or whatever, it would just be as smooth. It's not going to be slowed down by the block, but only if user wants to withdraw the money from this app chain to another, they have to wait until their transactions or their whatever assets that they're withdrawing from, they have to be settled on layer one first. So they have to wait until the app to build the block, send it to layer one, and layer one has to settle.
Yeah. So you're like, you're inside of this game or this platform, and then if whatever you're doing inside of here, it can be almost like whatever the speed is, 250.
Web 2.
Web 2 speed. Like you can do whatever you want. It only requires it to be like, when you want to withdraw, you're like, you want to leave this place, and you say, you know what, I'll take my money out, I want to take my transactions out. Then you have to wait until it's like fully settled, and that's the thing, which is just, it's not the speed of this, it's not the speed of TE, it's not the speed of the ZKVM. It's really like just the speed of how fast the Ethereum blockchain is. Then it's So that's a different thing, but that's
why there's Aclair, right? It's Aclair right now has to, for any cross-chain through Aclair, you do have to settle on Ethereum first, but we're going to support fast interop, which enables cross-chain interoperability, a fast cross-chain interoperability. And then when that works, it would just be the slowest. It's either going to be either your app chain is slower or Aclair is slower, but the slowest will be the one that will be the latency. And I think Aclair is going to be pretty fast. And this app chain, depending on your app chain design, it can be really fast too.
Yes. But
so in that case, the cross-chain transfer can be super fast, and you don't have to wait on Ethereum. That's what I'm trying to say.
Okay. So then I have a question for this. Let's say ZK Hyperliquid, right? For whatever reason, I don't know, like the front end, is it the front end? Let me think. I'm thinking, what happened if there was like a crash, right? Like the application dies. But I'm thinking, what is dying? Is it the front end that is there? Like you cannot access the front end, or is it something wrong with the TE, right? Or the thing that is submitting transactions? I'm thinking, which part is dying, and then which part is the biggest? It's like the main issue. I feel the front end is not the issue.
Depends, right? Depends on how you design the backend. For ZK layer 2s out there, the sequencer is basically the backend, right? and they have it openly available for everybody to call your IPC. But in a lot of app chains examples, you might design it to you only allow certain front ends to access your backend, right? You can't. It's just like normal Web 2 apps. You
Yeah.
wouldn't interact with their backends directly because you don't know how to. You only interact with their front end. So yeah, it can die if you just can't access their front end anymore.
Yeah.
You might not even have an explorer, which I think is totally fine if that's your design. It should all be just configurable. That's what I'm trying to say.
Yeah.
And but if you make your backend publicly available, then yeah, if the front end dies, then your chain still lives. But if your backend dies, which means your mempool, your match engine, all that stuff is dead, then yeah, your asset is stuck there. Yeah. Because you cannot produce a block proof of withdrawing records on your own. The app layer, the A to Z app has to do it. Yeah.
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 Unless there was
same-
this kind of
That's the same with ZK Layer 2, though.
yes, yeah, exactly. Like you're, but I guess with ZK Layer 2, you
can't. Yeah. Only Plasma, those kind of design, you can withdraw without the existence of the whatever sidechain thing. But ZK Layer 2, you just have to rely on the sequencer.
yes, yeah. Plasma is like Lightning networks. You just wait a certain period of time and then you can withdraw.
Yeah. I don't know too much about Lightning Network, but yeah.
Yeah, it's like it's based on channels, which is very different. Okay,
Yeah.
cool. Okay, so that's something to think about for the future. I guess I'm just like thinking about it. But okay, this is so then let me put it one other way. Now that you have this new type of architecture that you mentioned, and I do think it's I want to mention one thing, which is I think it's cool because all these different products that kind of existed, like P's, it's existed for a while, and then in the blockchain world, there's Oasis, there's like Secret Network, there's all these like T specific like chains and products, right? And then same with ZK VMs, like there's all these different variations of ZK VMs and they live independently. But what you've done is saying, okay, let's not just look at the technology. Let's see how these two different technologies, how they fit into an actual user flow. Like, how does it actually benefit the user at the end? And I think that's, to me, something really cool. And I like that. It's okay. So then if you were to compare this to a traditional like roll up or like a ZK like roll up, like what do you think is the biggest difference for like builders or for the users? Like what would you think is like their experience? Like what would be the biggest difference, you think?
Definitely, if you're an app developer,
Yeah.
then just deploying Solidity is way easier for sure. This requires you to build way more than just Solidity, but this also helps you enable a really powerful app that you can build. There's way more extensibility. There's way more things that you can do outside of EVM. You can't even hash properly on EVM. You have to use a catch hat, right? But in here, you can use Poseidon, the faster ones, or Poseidon 2, whatever. They all work as long as your ZKVM works, right? So it will be your choice, and you can configure that. It does require a lot more understanding, but what's wrong with that, right? If you are really trying to build an application that user enjoy using, put some hard works on the app itself. I think that's fine. Like we always talk about simpler DevX to onboard more developers, etc. But there's a lot of compromises in terms of like the underlying capability, right? Capacity, etc. So yeah, solving those. Yeah, I think it's just different markets, right? There are people who use Vercel to deploy their front ends, deploy their websites. There are people who use Wix. There are people who uses their own whatever stack to
Right,
react.
like there's people that use like full AWS or run their own hardware or whatever.
Yeah. So if your goal is really just about, hey, I just want to build a personal website, use Wix, use Framework.
Yeah.
It works, and they manage everything for you. If your goal is about, I want to build something a little bit more complicated, use Vercel, right? But if your goal is about, oh, my front end is an app, etc., it has a lot of functionality, you probably want to build it yourself. Same analogy you can parallel this to this blockchain app example. So I say this definitely fits certain needs for developers and also for them to build some magic for users. And I feel like this will have quite big of an impact for these developers who are really creative and who really knows the user's pain point, and they can really fully utilize this sort of a design philosophy to build this out. This is not a framework yet, just saying. This is inspiration. I'm just trying to
Yeah.
bring this idea out there, let people aware. And then, of course, it'll be nice to build out this framework if there's time and resources. So yeah, this is a little bit later in the pipeline. But yeah, if I have time later half of this year, I might build this out myself, this framework.
What do you think is more exciting to you? Is it the actual, let's say, ZK Hyperliquid, or would you say is this idea of this like A to Z like app framework thing? What do you think it's? Yeah, which one do you think is gonna make more money? Which one do you think is gonna be like more exciting? I'm just making jokes.
What do you think is the product market fit of crypto at this point, right?
Yeah, true.
It should really start from there. And I'm just gonna be realistic in this one. I think it's just finance, right? It's just DeFi. And you can, if you can build this ZK Hyperliquid on this, and it connects to Act layer natively, then it can, a lot of other chains like hyper performance, whatever transaction requirements, they can migrate into the ZK Hyperliquid and then do the hyper performance trading. And then for other like on-chain use cases that is not exchange, they can also like one click migrate back to other chains to do a lot of other stuff. It would just feels like one chain experience. And I feel like from that end, like this is a good product market fit. And of course, we are talking about gains. You can build a verifiable game using this framework too, right? Because it works. It's basically the same logic, but you probably change some of the names, the terms that I use to some game-related terms. Then you might realize, oh, it actually works for the game too. It can work with some other stuff, a lot of other things, because it's basically just Web2 with a trust layer. That's it. So yeah, this can be really scalable if those domain expert people start to understand this concept. And then really, and of course, that's first. You have to have creators, but you also have to have consumers. Who has a use case
You drive the demand first.
It has to be, for instance, not every game has to be finance, right? If the user's need is just having fun, what's the point of adding the finance component to it, right? Unless if it's a game that is in being incentivized using finance, then that's where you plug in the finance component. Then you can use this. So that's what I'm saying. It's like finding those like finance plus those kind of use cases and then apply this framework and have a Web2X, Web3 like trust. It's blockchain is scaling to the mass.
And about the cross-chain part, because that was something I was wondering a bit about. I'm like, you know what? In my mind, when I look at Web2 applications, there's very few applications that I know of that need to interact across platforms. Like for instance, if I'm on Instagram, like it's rare that I need to like directly interact with let's say Google, or directly interact with Shopify or something. It like maybe you use it to log in, but in general, each application is like its own little like world. And I think that's also the mentality of the Web2 world, where you build your application to be bigger and to be able to do more and more things. And that's, so my initial thought is like interoperability is not that useful for just regular Web2, like regular applications. But what I also noticed is that with finance, I do think that moving money across markets, across places, that's like actually like a very core thing, because money will always seek out the highest yield or the like lowest risk. And the markets change. Like sometimes market A is in this state, and then sometimes market B is in a different state. And then their relationship with each other changes all the time. So money has to flow across like the different worlds. And I think that's where interop and all of this like cross-chain, like cross-application stuff is probably going to be like really important. And I think that's something that I'm starting to pick up.
I feel like having this sort of interoperability layer, it's solving liquidity problem first, right? This is definitely the first, and then it's regarding messaging. There's a lot of things that on Web2 level that we don't see that how they're fetching other services. And also they're doing a lot of that in the back end. So we don't really see it, or we don't really see the cross-chain stuff. We don't need to initiate those stuff. But in the back end, there's always going to be, say, is fetching for a certain credential, like you said about ID, is fetching for certain data from another service. So all of those, it happens in the back end. Just if you look at like ChatGPT or Perplexity, right? It's doing search, it's doing a lot of, it's a lot of actions that is like third party, maybe not native to itself. And it has to fetch a lot of informations from third parties, like other places. So those kind of things, I say,
That's a good point. That's a good point.
Like I think the point of ACK-Layer, it should always be like people are not going to realize they're using ACK-Layer until they heard that, oh, this is actually powered by ACK-Layer. Like, it's not like that. I feel like that should be the case. That's why being a developer at Polygon, it's like me, because it's not for really end customer use cases, but more so or like a lower level dApp developers to really look, if they really want cross-chain interoperability, they look into it. And then they do it seamlessly so that users don't even realize that they're interacting with ACK-Layer.
I like that. I think that makes a lot of sense. Yeah. It's much more it's like application to application. It's not very interesting. Dang. Okay.
Yeah.
Do we want to what else? I wrote a bunch of other stuff too. Let me see.
All right, let me see too.
Yeah.
I wasn't even looking at the scripts.
Yeah, me neither. I just went with the flow. I like this.
You have a lot
like,
of questions.
Before this, we spent so much. I was like reading through all this. I was writing a bunch of stuff down, and I'm like, I guess it's already in our head, right? That's why. I think that
We covered a lot. Yeah.
We could. Yeah. This was a lot. The last thing is maybe just like privacy stuff, but I don't know if that's so important. Does this architecture provide more privacy to your trades, to your interactions, like on chain? Does it?
I think the privacy part, it's a configurable thing in this setting. It's because it's off chain, right? So it's private by default from the perspective of layer one, right? It's how do we configure those blocks? Do we want to verify the proof? Do we want to save the blob data on chain, or do we want to save it on a DA layer? And is the DA layer public, or is the DA layer private? And those kind of translates from I guess that's like the very minimum privacy. You can put more hardcore stuff on top of it, right? But I would say it's just configurable. And I don't have a specific example at this point, but it's like, because the execution itself happens in the backend, it's happening inside TEE. It's running certain programs, but if you don't know the input and the output, then it's private, right?
Yeah.
That's
true.
Yeah. You don't know the input and the output, but you just know that it's running the right program, that you trust that it's doing the right thing. Yeah. So as long as the server is not revealing the orders that users place, and also it's not revealing the results, the outputs that it calculated, then there's no way to see what happened inside, but you can still trust it.
Yeah.
So I think that's the logic of this privacy part. But of course, the privacy is also relevant to, say, is it from the perspective of a user being private? I can't see others' orders. Or is it the private to the point where even the server cannot see what's going on? Then you can use TE for that, right? You can always encrypt it, and then you can decrypt it inside TE, and then do the calculation, all that stuff. That you can also do that. Then even the server cannot see what's going on. What was the user's request?
Yeah. So the TE has the key, and then it has its own private key. All your interactions are encrypted, and it's the one that decrypts it. And that's cool too, right? Yeah. It's like an entire new design space, I feel. One last thing, maybe just on the Oracle stuff. Like, you guys picked this like order book thing, and the issue that Hyperliquid faced recently was essentially like an Oracle problem, where they did not accept the price from the real world Oracle feed, and
They manipulate the vault design.
like, what would that? Does it change it? now that, and maybe the first question is like, why does an order book system need an Oracle in the first place?
Hyperliquid is not an order book system, just saying. They're perpetual.
Okay.
Yeah, so they're actually their whole
Oh, yeah,
design is about order. Their whole
oh,
design is about Oracle. They have to follow
right. The
they have to
price of the
liquidate and all
actual.
that stuff with against the Oracle. So I'm just choosing their name because they're pretty catchy. People pay
Yeah.
attention. But this is a spot exchange, so we don't really need an Oracle. This Oracle that I've written here is more so of a communication portal between layer one and this app chain. Yeah.
I
So it's
guess
not
that was the thing that I was thinking is, yeah, you don't like, what do you need it? Like, you don't need one because it's just order books.
you
Like,
don't
whatever
need
price
one.
I'm willing to pay and you're willing
This
to
is
buy,
for
that's it.
cross-chain and probability. You need an Oracle that gives you the sort of tells you what the latest states that you can claim or you can bridge in the assets. Yeah.
But that's not related to the price, like to the
No, 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 no,
swaps.
no.
That's just for your,
I should have
that's more
said
like
it.
you
Yeah.
said, it's more some message transferring the states.
Yeah, the interoperability.
Yeah. Okay. So that's actually, but that's because you're using like an order book design. It's a spot like market, and
Yeah. So because of that, we don't need a price oracle, but we need this
mm,
oracle and we need the sender for cross-chain communication within Ackley. Yeah, that's another topic to talk about. Yeah.
yeah, maybe that's for the like a future. Okay. All right. Let's do it. Let's do a recap. What do we think about this very first
Yeah, we
discussion?
talked so much.
I know, man. I'm like, damn, went through quite a bit, to be honest.
Yeah, I didn't expect myself to talk so fast for this one. Maybe I'm
You
just
know
excited.
why? I think also when you're slightly more nervous, right? You just go in and you just go into all like the technical stuff. That's what I find.
Oh man.
I do it too. Like when I'm nervous,
Yeah,
like
exactly.
yeah, you just go deep. Yeah.
Yeah. I guess we really cover. I think that the thing that we covered about it's about in this new paradigm, right? I say paradigm because it is an inspiration, meant to be an inspiration that you can build any trustless. You can build an app that is trustless with a Web2 UX and then Web3 verifiability.
Yeah.
And yeah, the problem that we're trying to solve here is basically around user experience, right? But also providing this sort of a trust layer. And I think I started with explaining the decoupling of executions and the trust. And I say Eigenlayer was starting with it. They're the pioneers in proposing this kind of ideas. But we now started to explore with the advancement of ZKVMs, we started to explore, can we swap the AVS part into something like ZKVMs or TE, etc. And yeah, I guess like we started from there and then just start explaining the every single components of it, how to achieve it, right? And there's a lot of design things that we talked about. For instance, like you have instead of running the EVM on top of ZKVMs, now you can just run your app logics on top of ZKVMs or app state transition logics. So you're basically proving the app is transitioning from one state to another after all of these actions. And I think that's a key core concept of why these sort of A to Z apps are trustless, or you can trust them. And then the hyper performance part is where you just run the Web2 services. But if you want a little bit more trust in it, you can shield it inside, and you can wrap it in a TE, right? You can run that thing inside TE to make sure that the execution program, etc., is legit. You're not running a fake program. You're running a legit one that I can verify it against. So you have a correct execution, and then you generate a proper state transition proof, and then you submit it to layer one. And additional infra will be it comes with the box. It comes with AppLayer integration in a box, which makes assets coming in and out from that chain super smooth. Just be like one chain experience, ideally. Not right now. That's still work in progress. But yeah, that will be the ultimate user experience that I see.
That's the North Star, because I do think that what it looks like is Solana's unichain thesis. It seems like where Ethereum broke down is, I think, one, some of the performance stuff. And then the other part is really, to me, actually a lot of the interoperability parts. I think once interoperability is solved, where it feels like, I think the idea of a uni-chain system is really, it's more of a concept. It's as if, like, I think it's like the Turing test. Does it feel like one chain to the user? That's what at the end it's about. It's not like whether it is one chain or not. It's just if it feels like it to me, then that's okay.
Yeah. I would distinguish a bit regarding the term. Like Unichain, what I was referring to was the Uniswap chain.
No. That's what I'm not talking about Uniswap chain. I'm talking about this.
Yeah.
Okay. The single,
like unified chain. I don't know. Yeah.
Unified chain.
Yeah, they claim the right name for sure. Yeah.
I know, like single chain, like this idea of one big single like
chain experience.
Yeah,
because
like
you don't
big
think
L1.
about what kind of, when I call you from here to I'm in Bay Area, you're in Singapore, right? When I call you, I don't know where our call is being routed to. I don't know if it went through some sort of a server from here in US to Singapore, all that stuff. I don't know which kind of cable that it went through. I don't care. It should just be seamless. And that's what we're trying to build.
I agree. I think this ZK Hyperliquid idea, it is, I think to my knowledge, it seems like it's a very interesting approach to this. It's unifying two things: speed and performance and seamless like cross-chain interactions. And ultimately, it's like for the users, all of this is abstracted away. And yeah, I'm pretty I started the GitHub, bro. So I'm like I think the 6th person to start. If something happens, I better get rewarded. Okay, this is recorded.
I'm just gonna keep on building that demo to make it work fully, so people can reference it and then build their own version. Yeah, I hope the others can also reward us too.
Oh yeah, and this is done with
Root and Sol.